Okay, continuing on with Chapter 7, we have complex numbers. Complex numbers are in the form of a plus bi. Okay, the a is the real part, and the b times I is the imaginary part. So that's a complex number. And what those letters represent, a and b are constants, and I represents the square root of -1. Okay, since we can't really take the square root of a negative, they came up with a letter for it, and it's represented by the letter I. This is not a variable. This is fixed. I is always the square root of -1. Now, you want to remember you can break up square roots. For instance, you can break up the product of a square root. For instance, if you have the square root of a times b, you can break that up into the square root of a times the square root of b. All right, so for the imaginary numbers, for the square roots of negatives, let's say you have the square root of -64. That's going to be the same as the square root of 64 times the square root of -1. Okay, because -1 times 64 is -64. All right, we know the square root of 64 is 8. And we said a minute ago the square root of -1 is I. So that's the equivalent of 8 times I, or just 8I. All right, let's look at the second example, square root of -27. Okay, that's the equivalent of the square root of 27 times the square root of -1. Okay, because 27 times -1 is -27. Square root of 27 is the same as the square root of 9 times 3. And the square root of -1 is just I. Okay, this I is outside of the square root, by the way. All right, and we know the square root of 9 is just 3. So if I take the square root of 9, I can cancel out the 9 and bring the 3 outside. All right, so that's just going to be 3 radical 3 times I. All right, see if you can do number 3, example 3. All right, we have the 6. We'll start with a 6 plus square root of -8 is the same as the square root of 8 times the square root of -1. Again, we have a 6. 8 is the same as 4 times 2. Square root of -1 is just I. And the square root of 4, if I cancel out the 4, the square root of 4 is just 2. So it's plus 2 radical 2 times I. Again, that I is not underneath the radical. You may not need to use as many steps as I did. Okay, you can write it all under one radical if you want. If you wanted to write radical 4 times 2 times -1 and go from there, that's perfectly fine. All right, in these examples, we're going to combine like terms. It is the same thing with I as it is with a variable x. You can combine like terms. So here they want us to perform the arithmetic, write the sum or difference in the form of a plus bi, where a and b are real numbers. All right, so these are pretty easy. We're just combining like terms. Okay, these are all added. So they wanted the They wanted the real term first and the imaginary term second. So let's do it in that order. All right, pretty simple. We have 3 plus 4, so 3 plus 4 is just 7. And then we have negative 5i plus positive 8i. So that's just positive 3i. And that's it. Like I said, it's the same thing if the I were an X or a variable. You're just combining the like terms. If you want to do it vertically, you could. You could take the 8i and put it underneath, take the 4 and put it underneath. Pretty simple. All right, try number 2 real quick. I think most of you can do it in your head. All right, again, pretty simple. Combine like terms. I'm going to put the real number first, so the negative 6 is the only real number. And then 2i plus 9i, of course, that is positive 11i. All right, see if you can get number 3, please. All right, let's see. We have to simplify this. We have 7 minus the square root of negative 18 is going to be the same as the square root of 9 times 2. And I'll put the negative 1 as a separate square root. Square root of negative 1. Okay, 9 times 2 times negative 1, that's negative 18. We have plus 3. We have plus 5. And for radical 2, for radical negative 2, I'm going to make that radical 2 times radical negative 1. 2 times negative 1 is negative 2. All right, let's see. Let's do the reals first. We have a positive 7 and positive 3. So that's going to be 10. The square root of 9 is just 3. So this is negative 3 radical minus 3 radical 2. The square root of negative 1 is just I. And over here we have plus 5 radical 2. And again, the square root of negative 1 is just I. One more step. We have the 10. And we can combine these two. And why is that? Because they both have radical 2i. See this here? It's just negative 3 times radical 2i. And this is positive 5 times radical 2i. So negative 3 plus 5 is positive 2. And both of these have radical 2i. So it's positive 2, radical 2i. All right, simple one here, example 4. Please try it. All right, only step here is to distribute the negative. So let's see, we'll do the real first. Negative distributed to the 7, that's negative 7. I'm going to write it underneath. And then negative times 6i is negative 6i. I'll write it underneath. 11 minus 7 is 4. Negative 3 and negative 6i is negative 9i. Pretty simple. All right, please try this example here. Okay, let's see. We have a 7 plus, and we have the square root of negative 8. The square root of 8 is the same as 4 times 2. And that's going to be times the square root of negative 1. And distributing here, negative 1, and the negative of negative radical 18 The negative of negative radical negative 18 is going to be positive radical negative 18. Okay, because negative times negative is positive. Combining the reals, 7 minus 1, that's 6. Radical 4 is just 2. So this is going to be plus 2 radical 2. And the square root of negative 1 is just I. Okay, square root of negative 18 is the same as the square root of 9 times 2 times negative 1. All right, square root of 9 is just 3. So we have 3 radical 2. 3 radical 2, and the square root of negative 1 is just I. Now, once again, these constants are both multiplied times radical 2I. So we have the 6, 2 plus 3 is 5. And both of those are times radical 2I. Final answer. All right, so for this section, we're going to need to know the value of I squared. Now, of course, I squared is the equivalent of just I times I. And we said at the beginning, I is the square root of negative 1. And then the other I would be the square root of negative 1. When you multiply the square root of something times itself, you just remove the square root. So radical negative 1 times radical negative 1 is just negative 1. All right, so that's going to equal I squared. All right, in this section, they want us to write the product in the form of A plus BI, where A and B are real numbers. So it's pretty simple. It's the same as if the I were an X. It's the same thing. So 5I times 6I, it's basically the same as 5 times 6. And I times I. All right, 5 times 6 is 30. I times I is I squared. But we said a minute ago that I squared is negative 1. So if you see the I squared, you can cancel it and make it negative 1. And 30 times negative 1 is just negative 30. All right, so if you get I squared, just make it negative 1. You don't even need all these steps necessarily. All right, see if you can do examples 2 and 3, please. Let's see, number 2, we have 2 times negative 9, that's negative 18. We have I times I, that's I squared. All right, we said for I squared, you can cancel it and make it negative 1. Negative 18 times negative 1 is positive 18. All right, try number 3, and I'll give you a hint. You really don't even need to use I at all for number 3. All right, these are both multiplied. So let's see, the square root of negative 6 is the same as the square root of 6 times the square root of negative 1. And the square root of negative 9 is the same as the square root of 9 times the square root of negative 1, because 9 times negative 1 is negative 9. Now, these were multiplied, so of course when you break it up, these are still all multiplied. Now, does the order matter when you multiply? No, it does not. So we can do the square root of -1 times the square root of -1, and that's just -1. We know the square root of 9 is just 3. And can we break up radical 6? No, we cannot. So it just stays as radical 6. All right, so of course, -1 times 3 is -3. And the radical 6 is left over. Okay, now for examples 4 and 5, there's just an added element here. We have to use FOIL or the distributive property. Either one is perfectly fine. So let's do number 4 together. Okay, you're going to have to combine like terms. That's really the only extra step. First is going to be 4 times 5. That's 20. Inner is going to be 2i times 5. That's 10i. All right, notice it's the same thing as if this were 2x times 5, it would be 10x. So if it's 2i times 5, it's 10i. The outer is going to be 4 times positive 3i, that's positive 12i. And the last is going to be 2i times 3i. Well, 2 times 3 is 6, positive 6. And we said I times I is I squared. All right, so let's see. I squared is the same as -1, so I'll cross this off and write -1. And of course, 6 times -1 is just -6. And 20 minus 6 is 14. All right, and combining the like terms right here, 10i plus 12i is going to be 22i. So that's it. There's no I squared in your final answer because I squared is -1. All right, please try example number 5 in the same fashion. You can use FOIL or distribute. Since I used FOIL last time, I'm going to use distributive property this time. So let's do 8 times 8, that's 64. And then we can do 8 times positive 2i, that's 16i. And then we can do negative 2i times 8, that's negative 16i. And then finally, negative 2i times positive 2i. Negative 2 times 2 is -4. And I times I is I squared. Okay, we said I squared is the equivalent of -1. And of course, -4 times -1 is +4. So I'll make that +4. Okay, combining the likes, the real numbers, 64 plus 4 is 68. And positive 16, negative 16i, those cancel. All right, so for the complex conjugate, you basically change the plus minus sign. All right, this is plus minus sign on the imaginary portion. For example, if you have a complex number a plus bi, the imaginary portion is bi. So you just change the positive to a negative. So the complex conjugate of a plus bi is a minus bi. All right, if you multiply a complex number by its conjugate, it gives you a real number. So, for example, if you start with a plus bi and you multiply by the complex conjugate a minus bi, let's see what happens here. You distribute a times a is a squared. A times negative bi is negative abi. Bi times a is positive abi. And finally, bi times negative bi. Well, b times negative b is negative b squared. And of course, I times I is I squared. All right, we said before I squared is the same as negative 1. So we have a squared, negative abi and positive abi cancel. And negative b squared times negative 1 is going to be positive b squared. So, let's see. If you start with a plus bi and you multiply by its complex conjugate a minus bi, the result is going to be a squared plus b squared. So you just take the a and square it. That's the real part. And you take the constant term that's with the I, that's b in this case, and you square that and you add them. You'll see in the examples this will always work. All right, please pause and try these 3 examples. And remember, for the complex conjugate, you are changing the plus minus sign on the imaginary portion. All right, so let's see. Pretty simple here. Complex conjugate of 3 plus 2i. Complex conjugate for 3 plus 2i, the imaginary portion, is positive 2i. So we keep the 3. And the positive 2i just becomes negative 2i. Simple. All right, for negative 7 minus I, the imaginary portion is negative I. We keep the negative 7. And negative I becomes positive I. All right, finally, positive 10i. The imaginary portion is 10i. So the complex conjugate is going to be negative 10i. All right, please pause and try these 2 right here. So I'll do it the long way first, and then I'll use the shortcut. Distributing, 7 times 7 is 49. Inner is negative 14i. Outer is positive 14i. And last is negative 2i times positive 2i. That's going to be a negative 4i squared. All right, negative 14, positive 14, that's gone. I squared is the same as negative 1. So I'll cross off the I squared and write negative 1. And of course, negative 4 times negative 1 is going to be positive 4. 49 plus 4 equals 53. Shortcut. Remember, we said before, when you multiply the binomial by its conjugate, the answer is just going to be a squared plus b squared. So a is the real number, and b is the coefficient in front of I, the imaginary number. So for the shortcut here, a squared plus b squared, that's going to be 7 squared plus negative 2 squared. All right, you don't even have to write negative because it's squared. It's going to get positive anyway. So that's going to be 49 plus 4 equals 53. So same answer. It's not that much of a shortcut, but it's nice. It's good to know. All right, this one here. 1 times 1 is just 1. 1 times positive I is positive I. Negative I times 1 is negative I. Negative I times positive I is negative I squared. All right, plus minus I cancels. I squared is the same as negative 1, and the negative of negative 1 gives us positive 1. So we basically have 1 plus 1. All right, if you did the shortcut, the coefficient right here is a 1, and you would do 1 squared plus 1 squared. 1 squared is just 1, and 1 plus 1 is 2. So same thing, even with the shortcut. Right, in these examples, you want to perform the division, and you want to write the quotient in the form of a plus bi, where a and b are real numbers. Okay, so we're going to divide, but we want to get the answer in this form. So let's see. How do we get rid of an I in the denominator? Well, we can just multiply by I divided by I. And why am I allowed to do that? Because I divided by I is just 1. If you multiply by 1, it doesn't change the value, just the form. Also, you're going to get rid of the denominator because I times I is I squared. All right, so let's see. Distributing I times 3i is 3i squared. And I times positive 2 is positive 2i. And the denominator, I times I is I squared. Remember that I squared is the same as negative 1. And of course, 3 times negative 1 is negative 3. I squared right here is negative 1. And plus 2i, we can't do anything with that. Now, if you divide or multiply by negative 1, you just change the sign on each one of these. Negative 3 divided by negative 1 is positive 3. 2i divided by negative 1 is negative 2i. Final answer. All right, please pause and try this one right here using the same method. Okay, once again, we're going to multiply by I over I. Distributing I times 5i is 5i squared. I times positive 4 is 4i. On the bottom, 2i times I is 2i squared. Now remember, I squared is negative 1. And 5 times negative 1 is negative 5. Bottom, same thing. I squared is negative 1. And 2 times negative 1 is just negative 2. All right, so what are we left with? Negative 5 divided by negative 2. And these are both over a common denominator, 4i divided by negative 2. Negative 5 over negative 2 looks like 5 halves. 4 divided by negative 2 is negative 2, and we still have the I. All right, in this section here, we're doing the same thing. You want to write the quotient in the form of A plus BI. But in the previous examples, there was just one term in the denominator, just an I, and we can multiply by I over I. And now in these examples, there's two terms. Okay, what you want to do is multiply the denominator by its conjugate. All right. I should say numerator and multiply numerator and denominator. I'll just leave it like that. Multiply the denominator by its conjugate over itself. All right, so basically we're multiplying by 1 once again. Multiply the denominator by its conjugate over itself. So let's see, what do I mean by that? Well, here is the denominator, 6 plus I. What's the complex conjugate of 6 plus I? Well, you change the plus minus sign on the imaginary part, so that's just going to be 6 minus I. Now, we can't just multiply the bottom by 6 minus I. We have to multiply the top by the same term. And why is that? Because the same term over itself is just 1. All right, we're basically just multiplying by 1. So distributing 2 times 6, that's 12. 2 times negative I, that's negative 2I. 7I times 6, that's 42I. And 7I times negative I is negative 7I squared. On the bottom, the inner-outer terms should cancel. 6 times 6 is 36. 6 times negative I is negative 6I. I times 6 is positive 6I. And I times negative I is negative I squared. Let's see, 6I minus 6I is gone. I squared is the same as negative 1. And if you have the negative of negative 1, that's positive 1. So in the denominator, we have 36 plus 1. That's going to be 37. On top, we have a 12. We have negative 2I plus 42I. That's positive 40I. And remember, I squared is going to be negative 1. And negative 1 times negative 7 is positive 7. So on top, we still have a positive 7. You can really do this all in one step if you want. Okay, but the last step is going to be combine like terms. 12 plus 7 is 19. 40I is left over. And that whole thing is divided by 37. Now, really that would be the final answer, but they did say they want it in the form of A plus BI. All right, so we're technically supposed to break this up. Common denominator, 19 over 37. And plus 40I over 37. All right, you can put the I times 40, or you can put it out front. That's the same thing. All right, I just figured it looked more professional like this. Here's your real, here's your imaginary. All right, please pause and try this one right here using the same method. All right, multiply the denominator by its conjugate. So instead of 5 minus 2i, we have 5 plus 2i. And of course, you need the same thing in the numerator. All right, distributing on top, 4 times 5 is 20. 4 times 2i is 8i. Negative 9i times 5 is negative 45i. Negative 9i times positive 2i is negative 18i squared. On the bottom, since we did the conjugate, the inner outer should drop out. So let's see, 5 times 5 is 25. Negative 2i times 5 is negative 10i. And 5 times positive 2i is 10i. And negative 2i times positive 2i is negative 4i squared. If I were in a rush and I were doing this, I wouldn't even write the inner outer term because I know what drops out. I would just do it in my head. Negative 10i plus 10i. Anyhow, I squared is the same as negative 1. And negative 18 times negative 1 is positive 18. Combining like terms, 20 plus 18, that's 38. 8i minus 45i is negative 37i. Negative 10i plus 10i, that's gone. I squared is the equivalent of negative 1. And negative 4 times negative 1 is positive 4. Finally, like terms, 25 plus 4, that's 29. All right, remember we want it in the form of a plus bi. So we need that one extra step. Common denominator, 38 over 29. And negative 37 over 29. And of course, that last fraction is times I. All right, so for the complex plane, when you graph something like this, the real number is going to be on the x-axis and the imaginary number is going to be on the y-axis. All right, so let's take a look. So if we have the complex plane here, the xy plane, the x-axis right here, this is actually the real axis. Usually you just write RE. Okay, and the y-axis is the imaginary axis. Usually you just write IM. All right, so if you want to do something like 3 minus 4i, all right, the real number equals 3. And the imaginary number equals negative 4. Okay, you don't include the I, but you do want to include the plus minus sign. All right, and we said in the write-up, the real is the x-axis and the imaginary is the y-axis. So the real is going to be your x-coordinate, and the imaginary is going to be your y-coordinate. All right, so if we were to plot 3 minus 4i, first you go to x equals 3. All right, on the real axis, 1, 2, 3, and then you count down On the imaginary y-axis, -4. So -4 means you go down 4. Okay, so that would be 1, 2, 3, 4. Where do they meet? Right at that point right there. All right, so that's how you plot a complex number in the complex plane.